So good day everyone. Welcome to another video on physics for engineers. So today in this video we will be talking about dynamics, Newton's laws of motion. So for the first law of motion, it is the law of inertia. So every object continues in its state of rest or of uniform velocity in a straight line as long as no net force acts on it. So, yung object or particle will continue to move in the direction and same velocity uh, if there is no net force acting on it. So, kung merong forces na nag-a-act sa kanya, if you take the summation of forces uh, acting on it, and then if it is equal to zero, it will continue to move in that same velocity and same direction. Ganon din if the object is in a state of rest. So kung kinuha natin yung summation of forces acting on the object, it will if it is equal to zero, yung sum ng forces, the object will stay in its state of rest. So for the second law of motion, we have here concept of a system. The acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is in the direction of the net force acting on the object. So if we take a look of this particle right here, say for example, this particle, it is acted upon by a force 1 in this direction. So ito yung force. The particle will accelerate in the direction of the force acting on it. So say the particle or the force acting on the particle change its direction, the acceleration of the particle will also change in its direction. So, ganun din dito sa F3. So, if we take a look at this, kung mas malaki yung force applied sa object, mas malaki din yung acceleration or mas mabilis mag-a-accelerate yung ating object. So, meaning yung force is directly proportional to the acceleration. So we find that each time the particle moves in the direction of the force acting on it, and that the magnitudes A1, A2, A3 of the accelerations are proportional to the magnitudes F1, F2, and F3 of the corresponding forces. So if you take the ratio of the force over the acceleration, so if you take the ratio of the force 1 over acceleration 1, it will be equal to the ratio of F2 over A2 and same with F3 over A3. So that ratio is constant. So constant yung ratio na yon. The constant value obtained for the ratio of magnitudes of the forces and the accelerations is a characteristic of the particle under consideration. It is called the mass of the particle and is denoted by m. When a particle of mass m is acted upon by a force F, the force F and the acceleration a of the particle must therefore satisfy the relation F is equal to mass times acceleration. So when the particle is simultaneously subjected to several forces, if we must take the summation of forces on that particle, and that summation of forces will be equal to the mass times acceleration, wherein the acceleration will be in the direction of the acceleration will be in the same direction as the direction of the net force acting on the particle. So if we take the summation of forces, kung ano yung direction ng net force niya, yun din yung direction ng ating acceleration. So where the summation of forces represents the sum or resultant of all the forces acting on the particle. So for the third law of motion, whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first. So if we take a look at this, meron tayong swimmer dito. Yung swimmer, her feet exerts a force on the wall, and that force, meron nagka-counteract na force from the wall, na ito, force from the wall to her feet. So we call that normal force. So kung merong object na nag-exert ng force sa isang another object, yung object na nag-exerta niya ng force, wherein dito siya nag-exert sa wall, itong wall meron ding normal force or force na ibibigay sa paa nung swimmer. So this force will push the swimmer forward. So ayan. So let us head on to our examples para mas maintindihan ninyo yung laws of motion ni Newton. So first example we have here, what is the acceleration of two falling skydivers with a total mass of 132 kilograms including their parachute when the upward force of air resistance is equal to 1/4 of their weight? So after opening the parachute, the divers descend leisurely to the ground at a constant speed. What now is the force of air resistance on the skydivers and their parachute? So ito yung skydivers natin. So let us try to solve that. So una, sabi doon, yung ating skydivers, so ito, isang tao na lang i-drawing ko. Yung skydiver natin, hindi pa naka-open yung kanyang parachute. Ang sabi doon, yung air resistance is equal to 1/4 the weight of the divers. So ano yung weight nito? So let's say ito. So ito, kailangan natin i-drawing yung free body diagram ng diver. Ang kailangan natin dito is ito, drawing ng diver, and then we will take a look at the forces acting on the diver. So ito, syempre meron tayo ditong weight ng diver. So nag-a-act yung weight sa kanya. So that is what is pulling the diver downwards. So since hindi given yung weight, ang given sa atin is yung mass ng diver, we know that weight is equal to mass times gravity. So weight ng diver must be equal to mass ng diver plus yung parachute niya multiplied by gravity. So ang given natin dito is in SI, so gravity will be 9.81 meter per second square. So syempre, hindi lang basta-basta nagfo-fall yung diver, meron air resistance na nagpapabagal sa kanyang descent. So, yung air resistance, so sabi dito, air resistance, let us just call it FA na lang. So, FA. So, sabi dito, yung air resistance is 1/4 the weight of the diver plus yung parachute nila. So, meaning, FA is equal to 1/4 multiplied by weight. Yung weight niya is mg nung diver. So, 1/4 mg. So, dito, yung diver dito ay, if you take a look at the free body diagram, yung diver dito, we expect the diver to be accelerating downwards. So, nag-a-accelerate siya downwards. The net force or the summation of forces is equal to the mass of the diver multiplied by the acceleration, which is we expect the acceleration to be downwards. So, itong direction ng acceleration natin dito, maaaring tama, maaaring mali tayo. So, depende kung ano yung nilagay ninyo dito sa free body diagram ninyo, yun yung i-consider nyo na sign ng acceleration or nung MA natin. So, notes lang para sa pagsosolve ng problems natin, lahat ng forces in this direction upward and to the right, we will consider it to be positive. So, lahat naman ng forces na downward and to the left, we will consider them to be negative. So, yun. Para hindi ko na isusulat-sulat na ulit-ulitin dito sa summation of forces natin. So, let's try to solve this. So, una, we will take a look at the free body diagram of the diver na hindi pa inopen yung kanyang parachute. So, we will take the summation of forces vertical. So, this one is equal to, so if we take a look at the summation of forces, equal siya sa mass times acceleration. So, yung kanyang acceleration is downwards. Kinonsider natin na yung downwards to be negative. So, meaning, summation of forces FB will be equal to negative MA. So, now, tingnan natin yung FB natin, yung summation of forces in the vertical axis. So, we have here FA. So, FA is positive kasi upwards. And then, we also have here W, which is downwards, so negative. So, this one is equal to negative mass times acceleration. So, substitute natin, ang magiging itsura nito is FA is 1/4 mg and then minus mg yung ating weight. So, this one will be equal to negative mass multiplied by acceleration. So, ito. 1/4 mg minus mg. So, 1/4 minus 1 will be 0.75 mg. So this one is equal to negative MA. So, 1/4 positive minus 1 na negative. So, mas malaki yung negative natin. So, negative itong 0.75. If we try to divide both sides by negative M, so meron tayong negative side dito, negative 1, and meron tayong M dito. So, if we try to divide both sides by negative M, we will know that 0.75 G is equal to the acceleration of the two divers na naka-close pa yung parachute. So, let us try to solve for the acceleration. So, acceleration will be equal to 0.75 times gravity. So, gravity is 9.81 meter per second square. So, therefore, ang acceleration ng ating diver will be equal to 7.36 meter per second square. And ang kanyang direction, so ang nakuha natin dito is positive acceleration. Meaning, yung assumed direction natin dito na downwards ay tama. So, downwards yung direction ng acceleration ng divers natin. So, final answer. Pero hindi pa yan nagtatapos yung problem kasi tinanong doon, after opening the parachute, the divers descend leisurely to the ground at a constant speed. So, what now is the force of air resistance in the skydivers and their parachute? So, nung inopen nung skydivers natin, so, inopen na nila yung kanilang parachute. So, ganito na lang. So, kunwari, ito yung kanilang parachute. So, if we take a look at the forces acting on it, we will see that same pa rin yung weight nila, mass times gravity. And then, ang nag-iba, yung air resistance. Yung FA nila will be different now. Kasi, mas malaki na yung area na nag-a-act, kung saan nag-a-act yung air resistance natin. So, mas malaki na yung FA. So, hindi na siya equal sa 1/4 of mg. So, next, let us try to look at the movement nung naka-parachute na naka-open na. So, nung divers. So, ito. So, imagine niyo na lang na yan yung kanyang parachute. So, if you take a look at this, sabi doon sa problem that the divers descend at a constant speed. So, yung velocity nila ay constant. So, syempre, descent downwards yung velocity. Velocity nila is constant. Ngayon, ano yung acceleration if velocity is constant? Kung constant yung kanilang velocity, meaning yung kanilang acceleration is not uh, yung velocity nila ay hindi na nagbabago. Kung hindi nagbabago yung velocity, yung kanilang acceleration must be equal to 0. So wala silang change in velocity, meaning wala tayong acceleration. So yon. Now let us try to consider the summation of forces vertical na yung diver natin ay nakapag-open na ng kanyang parachute. So this one will be equal to mass times acceleration, wherein yung acceleration mo ay 0. So if acceleration is 0 multiplied by mass, any number multiplied by 0 must be 0. So summation of forces vertical is equal to 0. So ano yung mga forces natin dito? We have here the Fa, so upward. And then we also have here the weight. So downward siya, so minus W. So this one is equal to 0. Next, we try to consider the weight. So yung weight is equal to mass times gravity. So Fa minus mass times gravity. So this one is equal to 0. So tinatanong dito, what is the force of air? So ito yung kailangan nating hanapin. So Fa therefore is equal to mass times gravity. Transpose natin yung mg. So yung mass nung parachute plus nung dalawang divers stated sa problem na it was 132 kilograms. And yung gravity is 9.81 meter per second square. So Fa will be equal to, So dito ko na lang sulat sa taas. So Fa therefore will be equal to 132 multiplied by 9.81. So that would be 1,294.92 Newtons. So Newtons kasi kilogram meter per second square yung kanilang base units. So ito yung ating final answers. So next, we have here a window washer pulls herself upward using the bucket pulley apparatus shown in the figure. How hard must she pull downward to raise herself slowly at a constant speed? If she increases this force by 15%, what will be her acceleration? So the mass of the person plus the bucket is 72 kilograms. So let us try to solve this. First, let us try to look at the free body diagram of the window washer. So tingnan muna natin yung kanyang free body diagram. So dito sa window washer natin, alam natin na nag-a-act sa kanya yung kanyang self weight at saka yung weight ng bucket. So weight, ano pa yung nag-a-act sa kanya? So we also know that the wire right here has a tension. So meron ditong upward tension. So yung tension is always away from the body. So meron tension dito, and then for this, meron din tayong tension dito sa side na to. So ito yung mga nag-a-act sa system natin. And then if we try to consider itong tension na to, this tension right here is the force na ina-apply nung window washer natin. So, itong tension na to sa wire natin is the force that is being applied by the window washer. So, meaning, kung nakuha natin yung tension dito, we will know the force being applied by the window washer. So, T is equal to, let's say, yung force na ina-apply ng window washer be equal to F. So, T is equal to F. So, next, let us try to consider kung ano yung direction ng movement ng window washer natin. So, this one will be equal to window washer natin is she pulled downward to raise herself slowly at constant speed. So, constant speed meaning yung acceleration niya ay equal to 0. So, constant yung speed niya. So, wala muna siyang acceleration. So, ito, we will know that the summation of forces vertical acting on the system will be equal to 0 kasi yung acceleration nga niya is 0. So, yung forces applied dito in our system, we will see that there is ito, 1t and another t. So, meron tayong 2t dito na direction is upward, so positive, minus W. So, this one is equal to 0. So, we know that T is equal to the force being applied by the window washer. So, pwede natin substitute dito 2F, therefore, is minus W is equal to 0. So, since ang given dito ay yung mass nung window washer tsaka nung ating bucket, so W must be equal to mass times gravity. So, makukuha na natin yung force being applied by the window washer. So, substitute lang natin. We will get 2F, therefore, is equal to, transpose ko na itong W. So, mg, mass nung window washer was 72. So, 72 yung window washer plus yung bucket multiplied by gravity, 9.81. So, this one is equal to 2F. So, F therefore is equal to, divide both sides by 2. So, calculator nyo na lang. This one will be equal to 350, 3.16 newtons. So, next part of the problem, tinanong doon, if she increases this force by 15%, what will be her acceleration? Ano yung magiging kanyang acceleration? So, if she increases this force, yung force niya na ina-apply, so kung nag-increase yung force na yun, mag-i-increase din itong tension sa ating wires. So, kung nag-increase yung tension sa ating wires, upward yung tension natin, ang magiging acceleration niya, so we will expect her to be accelerating upward. So, MA, so ito yung figure natin. We expect her to accelerate upwards. So, MA will be upwards. So, ayun, let us try to consider the summation of forces na in-increase na yung kanyang pulling force, yung pag-pull niya sa wire. So, summation of forces will be summation of forces in the vertical axis will be equal to mass multiplied by the acceleration ng window washer. So, substitute lang natin. Let us first try to look at the summation of forces. So, forces applied will be same lang, 2T minus W is equal to, ang nag-iba lang, hindi na siya equal to 0. We are expecting a positive acceleration or upwards acceleration. So, mass multiplied by the acceleration. So, let us try to substitute. So, 2T, yung T natin is 353.16 minus W is mass multiplied by gravity. So, 72 multiplied by 9.81. is equal to 72 multiplied by the acceleration of the window washer. So if we try to solve for the acceleration, if you try ninyong i-calculator, the acceleration will be positive 1.47 meter per second square. So yung makukuha yung acceleration dito is going to be positive. So meaning yung acceleration natin na upwards, so upwards is tama. So tama yung assumption natin na upwards positive. So ito yung ating answer. So next problem or example, we have here a 3.2 kilogram paint bucket is hanging by a massless cord from another 3.2 kilogram bucket. Also, the as shown in the figure. If the buckets are at rest, what is the tension in each cord? And if the two buckets are pulled upward with an acceleration of 1.25 meter per second square by the upper cord, calculate the tension in each cord. So, ito. Let us try to solve this problem. So, una, consider muna natin yung mga free body diagrams. So, first, let us consider the free body diagram of the bottom bucket. So, ano yung forces acting dito? So, we know that it has its own weight. So, weight. So, since hindi given yung weight niya, ang given was, I think, if I recall correctly, yung mass niya. So, yun, yung mass niya yung given. Mass multiplied by gravity. Also, meron tayo ditong wire. So, always, kung merong wire, yung tension is always away from the system. So, T. So, meron pa tayong tension mamaya doon sa taas. So, let us just call this as T1 na lang. So, T1. Ang sabi sa problem, dito, if the bucket are at rest. So, at rest, meaning wala siyang velocity. Kung wala siyang velocity, wala din siyang acceleration. So, walang change in velocity, wala din acceleration. So, let us try to consider this free body diagram. Ang kanyang acceleration will be 0. So, ito muna. Sa bottom. Summation of forces, vertical. So, for the free body diagram nung nasa baba, so this one is equal to 0. So, T1, the tension 1 is upward. So, positive ito. Minus yung W. So, mass times gravity is equal to 0. Excuse. So, if we transpose mg, so T1 will be equal to mass times gravity. Substitute na natin 3.2 multiplied by 9.81. So, T1 will be equal to 31.39 newtons. So, ito kung naka-rest pa lang yung ating bucket. So, T1 or tension nung cable na nasa baba. So, if we try to consider the free body diagram nung nasa taas na bucket, so we will know that it has a tension 1. So, yung tension sa baba kanina, since connected sila, yun din yung tension dito. And then, we also have here yung weight mismo ng bucket. So, weight is equal to mass times gravity. And then, meron tayo ditong tension 2. So, iba yung tension dito sa taas. So, now, walang movement ito. So, meaning yung acceleration niya is 0. So, if we take the summation of forces in the vertical axis, so this one will be equal to 0. So, considering na natin itong free body diagram ng top bucket. So, if we take a look at this, ang upward force lang dito is itong tension 2. So, tension 2, nga pala, take note lang, palaging yung, kung nakakita kayo ng wire sa system, yung direction niya lagi is away from the body. So, away from the body. So, away din to from the body or system. So, T2 minus T1. So, T1 and then minus the weight of the bucket. So, this summation of forces is equal to 0. If we substitute yung ating mga given, so T2 we have here minus T1 is 31.39, and then we also have here the weight is 3.2 multiplied by 9.81. So, this is equal to 0. We will get that the tension in the upper cord is equal to, calculator nyo na lang, 62.78 Newton. So, ito yung tension ng cords natin. So, tension yung cord sa baba and then tension ng cord na nasa taas when the buckets were at rest. So, walang vent. So, next, tinanong din dito, if the two buckets are pulled upward with an acceleration of 1.25 meter per second square by the upper cord, calculate the tension in each cord. So next, let us try to consider yung bucket pa rin. Itong bucket natin, same pa rin yung mga forces applied. We have here the weight and the tension. Ang nag-iba, yung bucket natin will be, if we take the summation of forces, we will expect this bucket to be accelerating upwards. So, stated sa problem na it is pulled upwards. So, we will have here an acceleration upwards. So, MA. So, upwards yung acceleration na. So, let us try to consider the summation of forces vertical. So, E, ito. Sa free body diagram natin na ito, yung lower bucket na accelerating siya ng upward, given doon is 1.25 meter per second square. So, this one will be equal to mass multiplied by acceleration. So, positive kasi yung acceleration natin is upward. So, let us take the summation of forces vertical. So, we have here T and downwards yung W. So, minus W is equal to mass multiplied by acceleration. So, substitute natin, T therefore minus W. So, W is 3.2 kilogram multiplied by gravity 9.81 meter per second square is equal to mass nung ating bucket. So, 3.2 multiplied by the acceleration. So, sabi dun sa problem, it is accelerating upwards by 1.25 meter per second square. So, we will get that the tension, so let us call this tension 1 kasi iba yung tension natin mamaya doon sa taas. So, tension 1 will be equal to 35. Calculator niya na lang, 35.39 newtons. So, next, we have here for the free body diagram ng nasa taas na bucket. So, dito, meron tayong naka-apply na tension 1, yung from tension mula sa baba. And then, weight of the bucket itself. And then, tension 2, so away from the system, yung mga tensions natin. So, this one will be equal to, we expect acceleration upwards given naman sa problem. So, ito, MA natin is upwards. So, now, we try to consider the summation of forces para sa free body diagram natin na to. So, summation of forces vertical is equal to MA. So, ano yung forces dito? We have here T2 upwards minus downwards yung T1 and then downwards yung W. So, this one is equal to mass multiplied by acceleration. So, wait lang. Ayaw ma-erase. So, yan. So, mass multiplied by the acceleration. If we try to substitute, given na nakuha na natin yung T1 and then we know the mass of the object and the acceleration, also we know gravity. So, ang kulang na lang dito is T2. So, yun din naman yung hinahanap natin dito, yung tension ng wire na nasa baba at saka tension ng wire na nasa taas when the bucket is being pulled upward by 1.25 meter per second square. So, T2 therefore is equal to ito, T2 minus T1. So, 35.39 minus W, which is 9.81 multiplied by 3.2, and then this one, so wait lang, dito ko na lang susulat. So T2 minus 35.39 minus 9.81 multiplied by 3.2. So, gravity multiplied by mass is equal to mass. Yung mass ng object was 3.2 multiplied by acceleration, which is 1.25, accelerating upwards. So, T2 will be equal to, if we try to solve for T2, transpose nyo na lang itong dalawa dito, we will get 70.78 newtons. So this is the tension when the wires or the buckets are being pulled upwards. So next example, in the figure, the coefficient of static friction between mass MA and the table is 0.4, whereas the coefficient of kinetic friction is 0.2. What minimum value of MA will keep the system from starting to move, and what value of MA will keep the system moving at constant speed? So, for this example, we ignore the masses of the cord and the frictionless pulley. So, first, let us take a look at the free body diagram of the mass B. So, for this, MB is, ang naka-apply dito is, syempre, yung weight niya, which is, since given yung MB, so, mass multiplied by gravity, and then, meron tayo dito wire, so, yung kanyang direction is away from the system or the body right here, so, this one is T. So, sabi dito sa problem, what minimum value will keep the system from starting to move? So, assume natin dito na yung acceleration is equal to 0. So, 0 pa lang yung acceleration natin dito. So, now let us try to consider the summation of forces vertical of this free body. So, this one is equal to 0 since acceleration natin is 0. So, ano yung forces natin dito? We have here tension T, which is upward, so positive, minus, we have here the mass of B. So, mass of B multiplied by gravity, which is yung weight ng object B natin. So, this one is equal to 0. So, meaning, if we transpose this, yung tension T natin will be equal to mb multiplied by gravity. So, yung mass ng B is 2.0 multiplied by gravity, which is 9.81 meter per second square. So, tension on the wire will be equal to 19.62 newtons. So, next, let us try to consider the free body diagram of mass MA. So, hindi given yung mass MA, so ito yung hinahanap natin. So, of course, pinaka-importante, lahat ng body, meron tayo ditong self-weight. So, weight ng body, so WA, Let us call it WA. So WA is equal to mass of A multiplied by gravity. Also, we have here the tension on the wire. So away from the system. So pag ganito yung direction niya. So let us call this as T. And then we also have here the yung last na law ng motion, which is kung meron tayong force applied on another body. So meron yung body na yon ine-exert na force opposite sa nag-exert ng force. So dito nag-exert siya ng weight niya. So meron tayo dito opposite force exerted by the horizontal plane. So let us call this normal force N. And then given dito yung coefficient ng friction natin, so let us call this ito yung frictional force between the horizontal plane and the body or mass A. So ito meron na tayong free body diagram. Consider natin yung magiging acceleration ng ating system. So acceleration is equal to 0 kasi sabi doon what will keep the system from moving. So tinatanong yung mass nung A na hindi pa magmo-move yung system. So ito, kompleto na yung free body diagram natin. Let us try to consider the summation of forces vertical of this free body diagram. Hindi na itong free body diagram na ito. Ito na yung i-consider natin. So this one, wala tayong upward acceleration. So MA is equal to 0. And then, let us take a look at the forces applied right here. We have here upward force is the normal force. And then downward yung weight nung mass A. So minus weight of A. So this one is equal to 0. So if you take a look at the weight of A, substitute natin, mass of A is unknown. So MA multiplied by gravity is equal to 0. Ilipat natin tong MAG sa kabila. So N will be equal to MA multiplied by gravity. So di pa natin alam kung ano yung mass ng A. Next. So meron tayo ditong frictional force. So ang ating frictional force is equal to the coefficient of friction multiplied by the normal force. So anong coefficient of friction ang kailangan natin gamitin dito? Ang gagamitin natin is the coefficient of static friction kasi wala pang movement. Considered na not moving pa lang ito. So let us try to use mu s or the coefficient of static friction. So if this is mu s multiplied by n, F will be equal to, so mu s multiplied by, yung n natin is MAG, so mu s multiplied by MA times gravity. Yun yung ating force F. So now let us try to consider this free body diagram pa rin. Consider natin yung summation of forces in the horizontal direction. So this one is equal to 0. Wala tayong acceleration dito. Vertical and horizontal, 0 yung acceleration natin. So para dito, we have here forces applied is to the right, itong T, so positive. And itong frictional force natin, F, is to the left, so negative. So this one is equal to 0. So substitute natin. We have here T is 19.62 newtons minus F. So F is mu s multiplied by MAG. So mu s natin, static friction, is 0.4 multiplied by MA, mass of A. So, ito yung hinahanap natin multiplied by gravity which is 9.81. So, this one is equal to 0. Or if we transpose, nag-transpose tayo and then divide both sides by 0.4 and 9.81, makukuha natin yung MA, calculator nyo na lang, MA will be equal to 5 kilograms. So, dapat 5 kilograms para hindi mag-move yung ating system. So, minimum is 5 kilograms. So, answer. So, next, tinanong pa sa problem, what value of MA will keep the system moving at a constant speed? So, dapat yung movement daw ng system natin ay constant. So, ito na. So, ito yung ating free body diagram ng mass B. So, this one has a tension. So, ganito yung direction ng tension away from the system and its own weight. So, yan muna. So, yung MB natin, if the system moves, expected natin na yung movement ng MB ay downwards. So, meaning, this one will be equal to, so, drawing na lang natin, the mass of B multiplied by the acceleration of, wait lang, wrong. Velocity niya is constant, therefore the acceleration of B, the acceleration of B will be equal to 0 kasi yung, wait lang, hindi 0 yung velocity. Velocity niya is constant. So, kung velocity is constant, acceleration niya then will be 0. So, let us try to solve for the summation of forces vertical in this system. So, for system B, so hanggang dito lang. So, acceleration niya is 0. Mass times acceleration will also be equal to 0. So, ano yung forces applied dito? We have here T and the weight of the mass B. So, minus mb multiplied by gravity. So, this one is equal to 0. We will get the value of the tension in the wire will be equal to 19.62. So, 2 multiplied by 9.81. So, nasolve na natin to kanina. Same pa rin yung value ng ating T. So, next, let us try to consider the free body diagram naman ng A. So, same pa rin yung mga applied forces. We have here the weight of A, normal force N, and we also have here the force, frictional force, and the tension force. Same pa rin yung mga kung anong forces yung meron siya. Ang nag-iba lang dito is meron na siyang velocity this way. Pero yung velocity nitong body is constant. So, di natin alam kung anong velocity yan. Basta constant siya. So, kung constant yung velocity, wala siyang change in velocity with respect to time. Kung walang change in velocity with respect to time, yung acceleration will be equal to 0. Kasi ang acceleration is velocity, change in velocity with respect to time. So, ayun. Considering this free body diagram, let us try to take the summation of forces in the vertical axis. So, this one will be equal to 0 kasi 0 nga yung ating acceleration. So, 0. Ito, ano yung forces natin dito? We have here N, upwards. Downwards yung W. So, minus W mass of A multiplied by gravity. So, this one is equal to 0. So, next, we have here, since mag-iiba yung value ng A natin, MA, yung normal force natin kanina is iba na. So, if we transpose MAG, we will get that N is equal to M multiplied by AG. So, next, we know that the frictional force F is equal to mu multiplied by the normal force. So, mu multiplied by the normal force. Ang mag-iiba dito, kanina ang mu na ginamit natin is yung static coefficient of static friction. So ngayon, since the system is in motion or moving na siya, we must use the coefficient of kinetic friction. So mu k na yung kailangan natin gamitin. So mu k was 0. Ano yung mu k natin? 0.2. 0.2. So multiplied by n. So n was mag. So ma multiplied by gravity. So now let us try to consider the summation of forces in the horizontal direction. So for this body, so for the acceleration, 0 din yung kanyang acceleration. So mass times acceleration right here will be equal to 0. So let us take the summation of forces. So to the right positive, we have here t, and to the left is negative, we have here minus f. So this one is equal to 0. So substitute natin lahat ng given dito. So, wait lang, pakita ko lang muna. Minus f. F natin is mu n, which is 0.2 mag. So 0.2 mag. So this one is equal to 0. So substitute lang natin yung values natin dito. We have here t, 19.62 minus 0.2 multiplied by mass of A. Ito yung ating hinahanap. Multiplied by gravity, which is 9.81. So this one is equal to 0. If we try to solve for MA, we will get MA is equal to 10 kilograms. Wait lang. So, yun. So, 10 kilograms yung ating MA. So, kailangan na 10 kilograms yung ating MA para yung movement ng system will be kung nag-start na siyang mag-move, yung movement niya is constant yung velocity niya. So, ayun, kailangan muna mag-start siya mag-move para yung velocity niya is constant if the system is 10 kilograms yung mass A natin. So, we have here this example. The crate shown in the figure lies on a plane tilted at an angle theta is equal to 25 degrees with respect to the horizontal, and mu k, the coefficient of kinetic friction, is equal to 0.19. Determine the acceleration of the crate as it slides down the plane, and if the crate starts from rest 8.15 meters up along the plane from its base, what will be the crate's speed when it reaches the bottom of the incline? So first, let us take a look at the free body diagram of the crate. So for this incline problem, consider natin yung ating x-axis to be this direction. Ito yung direction ng ating x-axis. This direction will also be the positive direction of the x-axis, and this direction will be the positive y direction. So ito yung direction ng positive natin. So yun, erase ko lang to. So now let us take a look at the forces acting on the system or the crate. So unang-una, we have here the weight of the crate. So weight W. Also, we have here the normal force between the crate and this itong wedge. So N. Also, we have here frictional force F dito. So, meron tayong coefficient of friction. So, meaning, meron tayo dito frictional force. So, let us call that frictional force as force F. So, along the incline ito, force F natin. So, dito, kailangan natin yung component ng ating W para mas madali tayong mag-solve ng ating ah, problem. So, gamit lang ako ng ibang kulay. So, dito kailangan natin itong W along the y-axis. So, WY. And then, kailangan din natin itong W along the x-axis. So, WX. So, ito yung dalawang components ng ating W. So, kailangan natin itong dalawa. So, para ma-solve natin ito, kailangan natin ng angle dito. So, yung angle dito is the same as this angle. So, itong theta, wait lang, hindi masyadong makita. Ito. So, itong theta right here is the same theta right here. So, this one is equal to 25 degrees. So, this one must be 25 degrees then. So, now that we know that angle, we may take a look at the components of this W. So, WY will be equal to, since ito is 25 degrees and itong red na to ay yung W natin, we will know that the WY is equal to W. So, adjacent siya ng angle. So, cosine 25 degrees. And then, itong WX natin will be W. Since opposite siya ng ating angle, so W sine of 25 degrees. So, yun yung ating components. So, next, so this one will be equal to ito. Yung movement niya will be along the incline. We expect it to move along the incline with the acceleration in the positive x-axis. So, positive or down the incline yung ating direction ng acceleration. So, down the incline yung positive x natin. So, ayun. Now, let us try to solve for the summation of forces in the y-axis netong system natin. So, summation of forces in the y-axis is equal to 0. So, ano yung forces acting in the y-axis? We have here WY. So, WY, downward siya. So, or kabaliktaran siya ng positive y natin. Positive y is this direction. So, minus WY, negative WY, plus the normal force is in the positive y direction. So, plus N. So, this one is equal to 0. Wala tayong acceleration in the y direction. So, ang acceleration lang natin is in the x direction. So, this is equal to 0. So, we will know that N is equal to WY. Wherein, ang WY natin is equal to W cosine 25 degrees. Pero, N is equal to, yung given natin dito is not, hindi given yung weight niya. Ang given is yung mass ng ating object. So, N will be mg cosine 25. So next, let us try to take a look at the force F or yung frictional force natin. So F will be equal to, since we are expecting it to move, ang mu natin or coefficient of friction natin will be mu k. So, we expect it to move mu k multiplied by the normal force. So, ang F natin will be mu k multiplied by the mass of the object multiplied by gravity cosine 25 degrees. Kasi itong mg cosine 25 is equal to n. Sinubstitute lang natin dito. So, tuloy natin dito. So, ito yung mga forces natin. Wx, Wy, and then, ano pa? The normal force. I-redraw ko lang yung free body diagram. We also have here the frictional force, and we expect this to move in this direction. So, MA. So, Wy, i-recall lang natin, Wy was equal to W cosine 25 and Wx is equal to W sine of 25 degrees. So, tuloy natin yung pag-solve natin. Na-solve na natin yung summation of forces in the y-axis. Let us now try to consider the summation of forces in the x-axis. So, this one is equal to, hindi siya 0. Meron tayo dito ang acceleration, which is along the positive x-axis. So, summation of forces in the x-axis will be equal to mass multiplied by the acceleration. So, ayan yung hinahanap natin. So, substitute natin, or let us try to look at the forces right here. So, along the x-axis, we have here positive Wx and then minus hindi Wf, minus F, which is against yung direction ng ating positive x-axis. Positive is this direction. So, against yung F natin, so minus. Minus F is equal to MA. Wx is equal to W sine 25 and W is equal to mass times gravity. So, therefore, Wx is mass times gravity sine of 25 degrees minus F. Yung F natin was mu k multiplied by mass of the object times gravity cosine of 25 degrees. So, this one is equal to mass times acceleration. So, wait lang. Given ba yung mass ng object? So, walang given pala na mass ng object. So, we must divide both sides by the mass of the object. So, meron tayong m dito. If we divide this by m, makakancel ito. If we divide this by m, makakancel din ito. If we divide this by m, mawawala din itong m natin dito. So, ayun, pwede na pala nating makuha yung A kasi ang maiiwan na lang dito is yung acceleration. So, A therefore will be equal to G sine 25. So, 9.81 multiplied by sine 25 degrees minus mu k. So, mu k natin was 0.19 multiplied by gravity 9.81. So, cosine of 25 degrees. So, this one will be equal to the acceleration. So, acceleration lang yung naiwan dito sa side na to. So, if we try to solve for A, so A will be equal to 2.46 meter per second square. So, ang kanyang direction will be along the incline. Ito, 25 degrees. Along the incline yung kanyang direction. So, next, tinatanong doon sa problem, yung if the crate starts from rest 8.5 meter along the plane, up along the plane, from its base, what will be the crate speed when it reaches the bottom of the incline? So, tinatanong yung magiging velocity. So, madali na lang yun. Gagamitin na lang natin itong formula na to. Final velocity squared is equal to initial velocity squared plus 2 multiplied by the acceleration multiplied by the delta x or displacement. So, yung acceleration natin we expect the velocity to be the same direction as the acceleration. So, positive yung gagamitin natin dito acceleration. So, let us try to solve for V. So, V squared is equal to, wala tayong given na initial velocity. So, this one will be equal to 0. So, plus 2a. So, acceleration natin, na-solve natin kanina is 2.46 meter per second square along the incline multiplied by the displacement. It starts from the top. Ano yung displacement niya? 8.5 meter from the top downwards. So, 8.5 meter yung magiging displacement ng ating crate. So, V will be equal to, square root nyo lang itong side na to. So, V will be equal to 6 point, sorry, 6.33 meter per second. So, ang kanyang direction ng velocity will be along the incline. So, ito yung velocity niya. 25 degrees. So, that is all the examples. Thank you for listening.